Good morning, class. Here's chapter 1, functions, section 1.4, composition of functions. We've covered functions notation, domain and range, rates of change and behavior of graphs. Composition of function is being covered, and here's the objectives. Combine functions using algebraic operations, create a new functions by composition of functions, evaluate composite functions, find the domain of a composite function, decompose a composite function into its component functions. Recall rates of change and behavior of a graph. In short, we are referring to the slope of a line. More specifically, if you happen to have a curve and if you connect 2 points, everybody, any 2 points, the line that is created is called the secant line. And as always, how do you find the slope? Rise over rise. So this could be f of b minus f of a over b minus a. This could be delta y over delta x. Could be f of x sub 2 minus f of x sub 1 over x sub 2 minus x sub 1. For example, if you call this x sub 1 and you call this x sub 2. Or it could be f of x minus f of a over x minus a. If you call this, keep it as a and call this x. Or it could be f of a plus h minus f of a over h. If you keep this as a, this distance as h, and this becomes a plus h. Please understand they all mean the same. Even functions, f of minus x equals f of x, symmetric with respect to the y-axis. Odd function, f of minus x equals minus f of x, and it's symmetric with respect to the origin. For an even function for every point x and y on the graph, we also have the pair negative x comma y on the graph. For an odd function, for every point x comma 1 on the graph, the point negative x negative y is also on the graph. A function is increasing in an open interval for any choice of x sub 1 and x sub 2 in the interval. If x sub 1 is less than x sub 2, f of x sub 1 is less than f of x sub 2. That means increasing. And if this thing continues for a decreasing function, but f of x sub 1 is larger than f of x sub 2, so a function is increasing on an open interval for any choice of x sub 1 and x sub 2. If x sub 1 is less than x sub 2, the same. But f of x sub 1 is larger than f of x sub 2 is decreasing. And of course, a constant is a function is a constant on the interval. If for all choices of x in the interval I, the value of f of x are equal, meaning they are constant, they remain unchanged. Max and mean, formal definitions. Local, also known as relative, extreme value. Extrema is the plural of the Latin extremum. A local minimum is the minimum value within some open interval. Local minimum occurs at the point C in an open interval of a to b in the domain f of c less than or equal to f of x for all x values in the open interval. Here's a graph. Let me also give you the local max. Is the max value within some open interval. Local maximum occurs at the point in an open interval of a to b in the domain f of c larger than or equal to f of x for all x values in the open interval. In essence, peaks and valleys. Peaks are the local max, valleys are the local mean. Local mean, local max. Local mean, local max. Absolute, also known as global extreme values, are either maximum or minimum points on a curve. Absolute minimum occurs at the point C if f of c is less than or equal to f of x for all x values in the domain, as the graph indicates. Let me also show you the absolute max. Occurs at the point C if f of c is greater than or equal to f of x for all x values in the domain. Meaning, if you look at this one, local mean, local max, local mean. This local mean is also an absolute mean because no other point has a smaller y coordinate. Local max, local mean, local max. This local max is also an absolute max. Composition of functions. Operation on functions. If f of x represents one function, g of x represents a second function, and x is the domain of both functions, then the following operations on functions may be performed. Sum of functions, f plus g of x is f of x plus g of x. Difference of functions, f minus g of x is f of x minus g of x. Product of functions, f g of x is f of x times g of x. Quotient of functions, f over g is f of x over g of x, of course, as always. The denominator in this case, g of x, cannot be 0. And that's the synopsis of what was just mentioned. Let's look at this example. F of x is 3x plus 1, g of x is 5x plus 2. We want to find f plus g. Simply put, add them up. Just by definition, add them up. 3x and 5x, 8x, 1 and 2, 3, and we're done. Part B, f minus g. And by the way, and again, I'm telling you that you can find all of this under the modules of Canvas. Just sit back, relax, and make sure everything makes sense to you, everybody. F minus g means f of x minus g of x. Now, all we have to do, distribute this sign. So this becomes minus 5x minus 2 is to add up to negative 2x is to add up to negative 1. Part C, f minus g evaluated at negative 2. Because we already calculated this one, we don't have to go through the process. Just plug in negative 2. Negative 2 times negative 2, 4 minus 1, the answer is 3. Now, if we didn't have this, the second method would have been to plug in negative 2 in this, negative 2 in this, and subtract this one from that one. That would be a second method. No need to do that. If f of x equals x squared plus x minus 6 and g of x is x minus 3, let's do algebra of functions. F plus g of x, just add them up. And to do so, we add up like terms. So this one remains. They add up. Because this is plus, you don't need to change the sign. So we get 2x. Negative 6 and negative 3, they add up to negative 9. F minus g of x, by definition, is f of x minus g of x. And we must distribute. So we keep the first parentheses. We can drop the parentheses, but we keep them unchanged. Then we apply the negative to the second parentheses. We distribute it, and we get minus x plus 3. These two cancel each other. They add up to negative 3. So the final answer is x squared minus 3. Now, G minus F, it's important to know that it's not the same as F minus G. I have two ways to do it. Actually do their work. So let's quickly show you, and I'll give you the second method in a moment. So G minus F. So you just write the G and write the F and distribute the negative sign for this guy. So this remains unchanged. This is minus x squared minus x plus 6. Now, these two cancel each other. And these two add up to positive 3. The second method, and a faster method, would be, because we already have this, and this is the opposite of that, just write the opposite of that. So negate this and put it here, minus x squared, positive 3. That's all. Because G minus F is the opposite of F minus G, everybody. Algebra of functions. Now, we want to look at f times g given f of x equals to x plus 7 and g of x is x minus 4. Simply put, multiply the two functions. That's by definition. Which means you are going to FOIL, distribute the first one over the second one. So this gives you 2x squared minus 8x plus 7x minus 28. These two will combine into minus x. The remaining do not change. Do not change. They remain unchanged, the rest. We're going to continue with algebra of functions. Given f of x equals 16x cubed minus 12x squared plus 8x and g of x is 4x, and find f over g. Well, we just write f of x over g of x. You can write it right here that the denominator can't be 0. Or just ultimately over here, that means 4x can't be 0, x can't be 0. We can make up three fractions, everybody. Simplify all three as follows. This 4x squared, this minus 3x, and finally number 2. And of course, you have to write it somewhere that x can't be 0. Remember, 4x, the denominator can't be 0, which means x can't be 0. That's the meaning of it, everybody. Use the graph to find the value of f minus g of 0. Okay, we want to do that. Remember, f is the blue one, g is the red one. So f minus g of 0 by definition it means f of 0 minus g of 0. So if, just look at the blue one. Just look at the blue one. When x is 0, what is the functional value? What is the y value? This is the point. G is the red one. When x is 0, what is the y value, the functional value? It's 1. So 2 minus 1 equals 1. I hope everybody is clear. The functional value or the y coordinate of the function. We want same graph. G plus f of negative 3 by definition. It means g of negative 3 minus f of negative 3. G is the red one. So G, when x is negative 3, is this value, which is 4. And if the blue one, when x is negative 3, is this value, which is negative 1. So simply put positive 4 added to negative 1. So remember, this is 4, this is negative 1. And they add up to 3. Now we want g f of 2. By definition, g of 2 times f of 2. So g, the red one, when x is 2, the y is negative 1. If the blue one, f is the blue one, when it's 2, it's 4. So the product, negative 1 times positive 4, is the final answer. All right. We're going to continue looking at algebra of functions, everybody. For the functions f of x equals 2x squared plus 3 and g of x equals 4x cubed plus 1, find the following. So let's quickly do this. We want to add up the two functions. By now you have mastered this. And I like to put this in descending order. Because of plus sign, you can drop the parentheses. This comes first, this comes this second. Is to add up to 4. For f minus g, we write both of them, but this negative will distribute and give us minus 4x cubed minus 1, which means we put this one first. Again, I like to put it in descending order. Minus 4x cubed plus 2x squared. Positive 3 and negative 1, they add up to positive 2. F times G, you are foiling. So we multiply these two. We get 8x to the power of 5. And these two, we get 2x squared. And these two, we get 12x cubed plus 3. I didn't put this in descending order, but if we wanted, this goes before that, okay? I just wanted to show you the FOIL. And finally, f of x over g of x, just put 2x squared plus 3 at top, 4x cubed plus 1 at the bottom, and of course, the bottom can be 0. And you can work it out. We continue with the algebra of functions. F of x is 1 over x plus 2. G of x is x over x minus 1. And we want to find f plus g. So add them up. In order to add rational functions, or for that matter, fractions, you need to find the LCD. There is nothing in common between x plus 2 and x minus 1. Their product is the LCD. So this becomes 1 times x minus 1, and this becomes x times x plus 2. I'm assuming no one has any problem with adding fractions. So one more time. We are raising this fraction by multiplying the top and the bottom by x minus 1. So the top by x minus 1 is 1, the bottom x minus 1. This one, we are raising by x plus 2 over x plus 2. So we write the common denominator, and we want to add these two. To add these two, let me distribute this and write it as x squared plus 2x. And we're going to put them in this descending order. So x squared is first, x and 2x, they add up to 3x. And you should always put this in lowest term. The numerator cannot be factored, because you want two numbers, the product is -1 and the sum is 3. Can't be done, and we can further investigate it later when we look at quadratic equations with more details. The next one does the same thing, and I hope you recognize that the concept is identical to this one. Instead of plus, we're going to put minus. So we're going to write this one, we're going to write this one, and with a negative in between. So you really don't have to do anything. It's been already done. Just remember, plus sign changes to minus sign. Okay, and now I on purpose used one fraction because normally we do that. So the first one doesn't change. The other one, you have to change it to a minus. So let's write this as follows. So this is x minus 1 minus x squared minus 2x. So if we put the minus x squared first, x and negative 2x, they add up to minus x, and we have a -1. So I put it in descending order, everybody. The next one is just to multiply the two. So this is the product. And as you recall, when you want to multiply fractions, you multiply the tops, you multiply the bottom. That's why x times 1 is just x, and x plus 2 times x minus 1. And you don't have to distribute, you don't have to FOIL, because we really, it doesn't make any difference. The reason we keep it in this format, in case it can be simplified further. Now, of course, whenever you're dealing with a case like this, remember you have to write down what x cannot be. X cannot X cannot be negative 2 here. X cannot be positive 1 here. It's important to pay attention to that. Finally, f over g, just write it as such, and I hope you recognize this as a complex fraction. And to simplify complex fraction, you can multiply both sides, the top and the bottom, by LCD, or because really there's only one fraction at top and one at the bottom, an easier way would be this. You multiply the extremes, 1 times x minus 1. This would be the numerator. So x minus 1 is the numerator. You multiply these two, and that's the denominator. I hope you remember that. And again, x can't be negative 2 here, and 0 here. And as always, you have to look at these two cases also. So the result says x can't be 0, x can't be negative 2. Also, we remember that x couldn't be 1. In the case of a g, you should always pay attention to that concept. So pretty straightforward. Composite functions FOG of x. In the real world, functions frequently occur in which some quantity depends on a variable that in turn depends on another variable. Functions like this are called composite functions. In other words, x, as if you think of the function machine, x goes to g, becomes g, and goes to f, comes out as f, and the result is FOG. FOG of x is f of g of x. Substitute g of x for x in f of x to get f of g of x. GOF, or g of f of x. Substitute f of x for x in g of x to get f of g of x. This is g of f of x, my apologies. This is. So this is g of f of x. You want to distinguish between the two. So be very careful with that. And generally speaking, FOG and GOF are not the same. Okay. They become the same when they are inverse functions, everybody. When f and g are inverse functions, they become the same. Otherwise, they are not. Okay, it's important to know that. Now, another way of understanding this is this. So composite function f of g of x is f of g of x, g of f of x is g of f of x. So if you have g of x as 3x plus 1, and f of x as 1/2 x minus 3, we want to go from a to b, we plug it into this. For example, if I put 1, I get 4. If I put 3, 3 times 3, 9 plus 1, I get 10. If I put 7 times 3, 21 and 1, I get 22. Now from here to here, I have to multiply by 1/2 and subtract 3. So half of 4, 2 minus 3 is negative 1. Half of 10, 5 minus 3 is 2. Half of 22, 11 minus 3 is 8. Now, what if we want to go directly from this function to from A to C? We don't want the middleman, in essence, the middle function. Okay? We go through this process. F of g of x, so f of 3x plus 1. So into the f function goes the g function. Replace the x with the g, which is 3x plus 1. So half of 3x plus 1. So this is 3 halves x. This is 1 half minus 3. So let me just quickly show you. So this is 3 halves x plus 1 half minus 3. And these two add up to negative 5 halves. Okay. So in case you can see that. So that's the function, right? No middleman. Okay. The function is the composition of f and g and is denoted by FOG, read the composition of f and g, f composed with g, or f circle g. Now, here's what I want you to notice. I want you to look at this function. If I put 1 in here, I get 3 halves minus 5 halves, which is 2 halves or negative 1. If I put 3 here, I get 9 halves minus 5 halves, which is 4 halves or 2. If I put 7, I get 21 halves minus 5 halves or 16 halves or 8. So I can go straight from A to C using this function. And again, just plug in these numbers. You see that they work. Pretty straightforward, everybody. If f of x is 3x plus 8, g of x is 2x minus 5, we want to find the following. Let's start with f of g of 3. By definition is f of g of 3. By the way, you can find f of g of x and then plug in 3. But in any event, let's plug in 3 into g, the g function, replace the x with 3. 2 times 3 minus 5, 6 minus 5 is 1. And now put the 1 here. F of 1, put it in here, and you get 11. G of f of 3 by definition is g of f of 3. So that means plug in 3 into the f function. 3 times 3, 9 and 8, 17. Now put the 17 into the g function. That means 2 times 17 minus 5. 34 minus 5, 29. FOG of x. So into this function, replace the x with the g function, 2x minus 5. That's the meaning. That means 3 times 2x minus 5 plus 8. Six x minus 15. And these two add up to negative 7. Now, FOG of 3. So if I put a 3 here, what happens? 6 times 3, 18 minus 7, 11. So we can get it this way. G of f of x. So that means g of f of x. So instead of x, put 3x plus 8. We are going to distribute and we get 6x plus 18 plus 16, 6, 8 plus 16, 16 and negative 5, they add up to 11. Now, if I put number 3 here, 6 times 3, 18 and 11, 29. In other words, you can go through this process or find GOF of x and plug in. Either way will do the job. Now, f of x is 4x, g of x is x squared plus f, and we want to find both f of g as well as g of f. So f of g is f of g of x, which means f of x squared plus 2, which means replace this x with x squared plus 2. 4 times x, x is replaced, and we get 4x squared plus 8. G of f is g of f of x, or g of 4x, which means into the g function, replace the x with the f function, which is 4x. Now 4x, quantity squared is 16x squared, plus 2, and of course, as expected, in general, they're not the same, okay? In general, f of g and g of f are not the same, and as you recall from algebra before, they become the same when they are inverse functions. Okay, we know that. Algebra functions and their domains. Two functions f and g can be combined to form new functions f plus g, f minus g, f g, f over g in a manner similar to the way we add, subtract, multiply, and divide real numbers. Here's the sum function, the difference function, the product function, the quotient function. We've already seen that. So far, nothing brand new. If the domain for function f is a and the domain for function g is b, the domain of all of these functions would be a intersection. This looks like an N, an intersection. What's in common? A intersection B, because both f of x and g of x have to be defined. And for the last one, because we can't divide by 0, the domain of f over g is therefore x belongs to the intersection, and the bottom g of x cannot be 0. So we add this one to it. So more restriction, if you will. We want to find the domain for this function. As you recall, you're dealing with the square root. When the index is even, what's underneath must be non-negative. X is greater than or equal to 0 or 0 to infinity. For g of x, square root of 2 minus x, the same format. What's underneath must be non-negative. 2 minus x is larger than or equal to 0. That means 2 is larger than or equal to x, or x is less than or equal to 2. And the domain would be negative infinity to 2. What would be the domain for f plus g of x and f over g of x? So let's discuss part C first. In other words, composition. Remember, basically, it's the intersection of the two for the first one. Now, what is the intersection of the two? Just to make sure we see that, sometimes graphing would be helpful. Here's A, which goes from 0 to infinity. That would be A, right? From 0 to infinity. The B is from negative infinity to 2. So the green one is B. So when they come together as intersection, I hope you recognize this is the only answers from 0 to 2. Both 0 and 2 are included. What happens for the last part? The denominator can't be 0. In other words, the same thing, but whatever in this makes the denominator 0 is out. So the same as this one, but what makes it the denominator 0 is out. What makes this 0? X equals 2. So the 2 is out. That's why we put it in this format. So A intersection B and G can't be 0 is 0, comma 2. You really don't have to write this because it's, I don't want you to confuse that with that one. Just this one. Here's the answer. So a quick recap for the whole page. X greater than or equal to 0, 0 to infinity. 2 minus x greater than or equal to 0, minus infinity to 2. When we put this together as an intersection, meaning what's in common, gives you 0 to 2. Is 0 included? Yes. Is 2 included? Yes. The same thing happens here, except anytime you divide by a number can't be 0 or by a function. So this can't be 0. So you set this equal to 0. It's 0 when x is 2, and you exclude that. So how do you exclude the 2 from here? Bracket changes to parentheses. Pay attention. This is closed interval. That means 0 is included, 2 is included. This is half closed, half open, meaning 2 is not included. Suppose that y is f of u, square root of u, and g of x is x squared plus 1. Y equals f of u, that means f of g of x, or f of x squared plus 1, or square root of x squared plus 1. You put the x into g, the result comes out as g of x. You put that into f, the result comes as f of g of x, or f of g. A composite function, f of g of x is f of g of x. We are repeating that. The domain of f of g is the set of all x in the domain of g, such that g of x is in the domain of f. In other words, f of g of x is defined whenever both g and f are defined. So this gives you idea, the same concept, domain of f of g, range of f of g. G of x must be defined, so any x not in the domain of g must be excluded. f of g of x must be defined, so any x for which g of x is not in the domain of f must be excluded. Let's make sure we understand this by looking at a very simple example so we understand the concept. It's a lot easier than what you see explained here. We want to find the composite function for f and g, where f is x squared, g is x minus 3. F of g is f of g of x. That means replace the x with x minus 3. So f of x minus 3, which means x minus 3 squared. And you can keep it as that. You don't have to square it. What is g of f? G of f of x. That means g of x squared, which makes this x squared minus 3. There is no restriction, okay, for any of them. F of x squared of x minus 3, g of x is x squared, h of x is x cubed plus 6. We want to find f of g or h. First, let's find a portion of it. That means, for example, f of g. You can do it in any order you want. You can find g of h first and then f of g of h, or just first find f of g. Never mind oh. So f of g is f of g of x, which means here's the f function. Replace the x with g, which is x squared. So you get square root of x squared minus 3. Now, f of g o h, that means f of g of h, f of g of h. So replace this with h. That's the meaning of it. Express capital F of x, which is square root of x plus 2 over x, in the form of f of g. In other words, find f of x and g of x. And this is only by inspection class, and this is not unique. Okay, this is not unique. For example, if this is f of g, you can say the f function is x plus 2 over x, and g is the square root of x, just as an example. By inspection, meaning you calculate f of g from here, it must give you that. And this is by inspection. You have to eyeball it and see what will make it work. But it's not unique. I make some, this is probably the simplest format you see, and it comes to you first. But just as an example, so you see why it's not unique. If I make the numerator x plus 1 and the bottom x minus 1, then I make this one square root of x plus 1. Notice, if I replace the top with this, I get square root of x plus 2, and the bottom with this, I get square root of x. So this would be a possible solution. Of course, I believe this comes to mind first, but in case. All right, use the given graph of f and g to evaluate each expression, or if the expression is undefined, enter undefined. So we want f of g of 2, which means from here, and the g function is the blue one, the f function is the red one. So first and foremost, find g of 2. So in this function, when x is 2, when x is 2, y is 1, 2, 3, 4, 5. So that means you want f of 5. So when 1, 2, 3, 4, 5, when x is 5, on the red one, you're looking for this one having y coordinate 4. G of f of 0, that means we want f of 0 first. F, again, the red one. And f of 0 is this point which has a y coordinate 0, so you want g of 0. And g of 0 is this point which has a y coordinate 3. I hope everybody is following that. I'm showing you exactly and precisely how to find this. However, f of g of 0, that means f of g of 0, and we know g of 0 previously, we know it was 3. So that's why, I didn't do that again. So g of 0 is 3, right? So we want f of 3. F is the red one, locate the 3. Okay. And 3 has a y coordinate 0. So again, 1, 2, 3, 4, 5. You can put the numbers if it makes it easier. Along the x and the y-axis. G of f of 6. That means we want g of f of 6. That's the meaning of it. That means first find f of 6. So find the 6 along the x-axis. And for the f, the red one, 6 is here. The y coordinate is here. And this one would be 1, 2, 3, 4, 5, also 6. So you can put the numbers along the x. G of 6. And this value is not defined because when you look at the blue one, it stops here. So x, after this number, when it gets larger, we don't have anything about the function. This value is not defined because there's no point on the graph of g that has x coordinate 6. G or g of negative 2 by definition means g of negative 2. The g function is the blue one. So this is negative 1, this is negative 2. So we are referring to this point, which means y coordinate 1, and g of 1, this is 1, seem to have the y coordinate 4. F of f of 4, that means f of f of 4. Now, what is f of 4? Let's locate 1, 2, 3, 4 along the x-axis, and the f function is the red one, is the red function. So we are looking at this point. which has a y coordinate 2. So that means we want f of a 2, and you say 1 and 2, the y coordinate is -2. I highly recommend you watch this a couple of times to be on the safe side. Application. An oil tanker is leaking oil and we want to determine the area of the circular oil patch around the ship. The oil is leaking from the tanker in such a way that the radius of the circular oil patch around the ship is increasing at the rate of 3 feet per minute. Okay. So we are interested in finding the area. And remember, what is given? The radius is increasing 3 feet per minute. So R of t is 3 times t, 3 feet per minute. Okay. And the distance that covers R is the distance, is rate, which is speed times the time. How much time? I don't know about t in general. So t represents the general time as it appears. Number of t is the number of minutes. Okay. Number of minutes. And then 3 times that. Area is pi r squared. So simply put, you have to replace the r by composite function. We can find the area of the oil patch as a function of t as follows. A of r of t is a of 3t, which means replace the r with 3t, everybody. So pi times 3t quantity squared. This is 9t squared, becomes 9 pi t squared. So the area is called a of r of t. A of r of t is using composite function. So a of r of t is called a composite function. We have only a couple more questions to go. Finding f and g such that f of g is h of x, x squared plus 1 to the power of 50. When we want to decompose that in that sense, class, that means we want the components. It's by inspection, class, by inspection. And normally the easiest function that comes to mind, the first one is the right one. So think about this. The entire thing is being raised to the power of 50. So that would be the shell function, the outer function. So it makes sense something to the power of 50. So x to the power of 50. The inner function, the g function, the inner function is x squared plus 1. Now notice f of g will do the job. X goes to g, g goes to f. G of x is x squared plus 1. This is the h function, which gives you x squared plus 1 to the power of 50. And again, after you find it, you must check your work. You could say f of x is x plus 1 to the power of 50, and then g of x is x squared. That's what I mean. It's not unique. Here's the second one. If you use f of x as x plus 1 to the power of 50, normally this comes to mind first. Replace the x now with x squared, it does the job. So it's not unique, but this would, I believe, come to mind first and foremost. What about this one? The outer shell, the function seems to be 1 over x cubed. The inner function, g, seems to be x minus 4. And again, this is by inspection. If you do the FOG, you get to the same answer. f of g or f of g of x, you get the answer. But as an example, what if you said f of x is 1 over x? If you said f of x equals 1 over x, then g must be x minus 4 cubed. And that's what I mean. It comes to us by inspection. And now the last one, we want to find the domain of a composite function. And I'm going to look at this when it gets involved, such as rational functions, two different methods. So f of x is 3 over x minus 5, g of x is 2 over x plus 1, and we want to find the domain of f of g and g of f. So two methods. We are interested in f of g. What f of g, whatever is in g that must be excluded must also be excluded from f of g. Whatever is in f that must be excluded also must be excluded from g of f. So right away from here, x cannot be negative 1. Recognize that. So this is one method. So exclude negative 1 from g, right? And therefore, the domain of f of g. Then you look at f of g, where f of x is 3 over x minus 5, and x can't be 5. F of x, x can't be 5. If x can't be 5, and we are replacing it with g of x, then g of x can't be 5. So this is the first method. Pay attention and compare and contrast, see which one is easier for you. So therefore, g of x can't be 5, which means you're going to set g of x equals 5 and exclude it. G of x is 2 over x plus 1, can't be 5. And we do the cross product. This is 2. This is 5x plus 5. If I take it this way, I get negative 3 equals 5x. So x equals negative 3 over 5, and it's not equal to that, remember. It can't be equal to that. Therefore, we have to exclude negative 1. We have to exclude negative 3 over 5. So the domain, x can't be negative 1 from here. X can be negative 3/5 from here. And you can write it as an interval format, but this is an easy way of excluding that. And that's absolutely fine. We are going to look at the second method. We are going to write what should be excluded from each one. From this one, x can't be 1. From this one, x can't be negative 1. Then we look at the composite function that we want, in this case, f of g. Which means this is of interest to us. And then we actually find f of g, which is f of g of x. We are going to find f of g. So 3 over x minus f of 2 over x plus 1. 3 over x minus 5, you replace the x with the g function. This is a complex fraction. You multiply the top and the bottom by LCD, namely x plus 1 over x plus 1. So this becomes 3 times x plus 1. This becomes a 2, because this cancels this one. We are multiplying everything by x plus 1, minus 5 times x plus 1. I hope everybody understands what we are doing here. And so this is 3x plus 3. This one, let me write this. This one is 2 minus 5x minus 5. And therefore we have 3x plus 3 per minus 5x minus 3. Please understand, I can take the negative sign out and put it in front of a fraction bar. Makes no difference. Now, here's the second method. The second method, we have to choose one of these. Which one? The one that it's the inner function. You want f of g. G is the inner function. So you have to choose x can't be -1 from here. And also from the result, what is it that x cannot be? The denominator, 5x plus 3 equal to 0. X can't be -3 over 5. So you exclude -3 over 5 from the result of f of g. So in other words, find f of g. You can see the domain easily. And then, because it's f of g, you look at domain of g. -1 from here. And as you can see, exclude both for the domain of f of g, and that's exactly what we got. I'm going to leave GOF for you, but let me quickly explain. If you want to go with this method, you keep these two, and this is the one that you have to bear in mind, because for GOF, f is the inner function. And then find GOF just like I did it here, and exclude what you must. So you are excluding two things. You're excluding this number, and then whatever the result of GOF is. This is the second method, everybody. You can also do the first method if you like.